Hello everyone. Today I'm going to solve some equations with radicals. I will do it by establishing systems of equations. The first one, the cubic root of x plus 7 plus square root of 10 minus x equals 5. We have two radicals here, one cubic root, the other is square root. Let u equals the cubic root and v is the square root. Then immediately we have u plus v equals 5. This is the original equation. Additionally, u cubed equals x plus 7 and v squared is 10 minus x. Using these two equalities, we can eliminate x by adding them up. U cubed plus v squared equals 17. So we established a system of equations in u and v. U plus v equals 5, u cubed plus v squared equals 17. The first equation is a linear one. So we can solve for v in terms of u, v equals 5 minus u, and do a substitution into the second equation. We end up with a cubic equation in u cubed plus u squared minus 10u plus 8 equals 0. Look at the coefficients of the equations, 1, 1, negative 10, and 8. They sum up to 0, which means u equals 1 is a root. So we can do the factoring, u minus 1. The remaining part is a quadratic polynomial in u. We can do further factoring. So we have u minus 1 times u minus 2 times u plus 4 equals 0 with 3 roots of u, negative 4, 1, and 2. By the definition of u, which is the cubic root of x plus 7, we have x equals u cubed minus 7. Therefore, we find all the roots for x, negative 17, negative 6, and 1. We are done for the first one. The second equation. This equation has a couple of square roots in fractions. Again, that u equals the square root of 3 plus x squared, and v is the square root of 37 minus x squared. We can square both sides of the equality and sum up to eliminate x squared. We have u squared plus v squared equals 40. And we also notice that both u and v are positive because they are square roots. Then we establish a system of equations in u and v. 1 over u minus 1 over v equals 1/3. This is the original equation. And u squared plus v squared equals 40. From here, we can definitely solve for u in terms of v from the first equation and make a substitution. We are going to end up with a fourth order equation. This is definitely doable, but I'm going to introduce another trick here. From the first equation, we have 3 times v minus u equals u times v. So we just multiply all the denominator u, v, and the 3 on the first equation. We introduce another variable t to be u minus v. Then we have u times v equals negative 3t. So therefore, t is negative. So this one, we establish a relation between t and uv. And from the second equation, u squared plus v squared can be rewritten as u minus v squared plus 2uv. Then we have t squared plus 2uv equals 40. So we establish another relation between t and uv. We plug in uv equals negative 3t, and to the second equality, we end up with a quadratic equation in t. Because t is negative, we have only one negative root for t, which is negative 4 here. So u minus v, which is t, negative 4, and u times v, which is negative 3t, that is 12. This system of equation is easy to solve, and we are only looking for positive solutions. They have two pairs of solutions, one positive, one negative. The positive one, u equals 2 and v equals 6. Again, by the definition of u, square root of 3 plus x squared is u, which is 2. Square both sides, we have x squared equals 1, and therefore x is positive or negative 1. We are done with the second equation. The third one, it contains a couple of nested square roots. Once again, let u equals the first square root and v equals the second square root. So we have u plus v equals 6. Additionally, so look at the definition of u and v. Inside the square root is x plus a square root, and v is x minus a square root. If we multiply them, they can be simplified. Eventually, we have u times v equals 9. So we establish a system of equations in u and v. By Viacha's formula, u and v are the roots of t squared minus 6t plus 9 equals 0, which has a double root, u equals v equals 3. So u is 3. The embedded square root is 3. We squared both sides. We have x plus square root of x squared minus 81 equals 3 squared, which is 9. We move x to the other side and squared again. We have x squared minus 81 equals 9 minus x squared. This is not a quadratic equation. Both left-hand side and the right-hand side have square root, have x squared cancelled out. So we end up with a linear equation with root x equals 9. And we're done. An exercise. Verify that this expression is a root of x cubed plus px plus q equals 0. This is so-called Cardinal formula. It looks complicated, but if you use the trick we are discussing today, it is surprisingly simple. This might be a topic of my future video. That's all I have for today. Thank you for watching.